YouTube, welcome back. Today we continue our series in design a key value store. We building the system design for a key value store. Today we are going to talk about data partitions. Let me just cover it here. Data partition. Data part. So basically, let's start. What is data partition? Data partition is, or why we need it, like. So in distributed systems, for large applications, data partitioning, also known as data sharding, is a database design technique used to split the large data set into smaller, more manageable pieces called partitions or shards. Each partition contains a subset of the data and can be stored on separate servers or storage devices. Data partitioning offers several advantages in terms of performance, scalability, and manageability. And basically, for large application, it is infeasible to fit the complete data set in a single server. The simplest way to accomplish this is to split the data into smaller partitions and store them into multiple servers. And we have two challenges while partitioning the data. We have the first one is distribute data across multiple servers evenly, and the second thing is minimize data movement when nodes are added or removed. So a good thing to solve this problem is using a consistent hashing, and we have a video about consistent hashing. I highly recommend you to watch it. So basically, a consistent hashing is a technique that we use. Let me just put the ring here. Okay, that's decent. That's decent. So let's put it down there. So a consistent hashing is a technique used in distributed systems and distributed databases to efficiently distribute data across multiple nodes or servers, while minimizing the impact of adding or removing nodes from the system. It is particularly useful in scenarios where the number of nodes can be changed dynamically, such as in content delivery networks, or maybe in key value stores, like in large data sets. So let's see how this will work. So we have this ring, and let's say that we have our servers here. So let's say that we have 4 servers, okay? And we have, let's say that we have key. This key, oh, this is white, it's black. Okay, we have a key here, and a key here, and a key here, and a key here. And let's just make this smaller, and a key here. So basically, we want to distribute the data across multiple servers evenly, and basically here we are distribute the data. Each key will be stored in specific server or specific database that being closest to it, moving clockwise. So we move clockwise like that. So we find this for this, and this for this, and this for this. And we can use something called virtual nodes. So basically, each server will be represented by more than one position in the hash ring. So basically, we make sure that all the data has been distributed evenly. And when a specific server is gone, for example this one, the only affected nodes that will be the nodes that being stored in this server, and the other nodes will have no effects. So this node will be stored and will be replicated in this server, and we will talk about data replication in next video. So basically here we have the consistent hashing as we discussed right now, is a great technique to solve these problems. So let us revisit or rethink about how this will do. So let's just assume that, let's just give it names because it will be quite important. So this will be server 0, and no, what? Delete this one, and this is server 1, 2, 3, and this is server 2, and this is server 1. So basically, and we have this key, we have key 1, key 2, key 3. So first, servers are placed as in a hash ring, as you can see here, and the key is hashed onto the same ring. Like we have 4 keys here, and each key has been hashed in the same ring, and it is sorted on the first servers and counted while moving in the clockwise direction. For instance, this key, let's say that this key number 0 will sort in server 0, this key 1 will sort in server 1, key 2 server 2, key 3 server 3, and etc. So using consistent hashing to partition data has the following advantage. We have the automatic scaling. Server could be added and removed automatically depending on the load. The other thing, the number of the virtual nodes for a server is proportional to the server capacity. For example, servers with higher capacity are assigned with more virtual nodes. So basically this is called the heterogeneity. And we have that, and yeah, that was it for today's video. And let's just make a quick recap about the data partition again. So basically, data partition, also known as data sharding, is a database design, a technique used to split the large data set into smaller, more manageable pieces called partitions or sharding. Each partition contains a subset of the data and can be stored on separated servers or storage devices. Data partitioning offers several advantages in terms of performance, scalability, and manageability. And we use consistent hashing in data partitioning. So basically, we have 4 servers that used to store the data, and we have 4 keys. Let's say that we have only 4 keys, and one server can have 1 key only. So to store them in more evenly, we use consistent hashing. And the good thing that consistent hashing, it's easy to scale up or scale down. So basically, if we have more keys, for example, let's just have more keys, we add more servers, if we have more keys, we add more servers for them, and it's easy to add servers or remove servers, and also we can create virtual nodes. So basically which means that each server will have more than one position in the hash ring, which will mean that we could make sure that we are distributed the keys more evenly across multiple servers. So that was it for today's video, and I hope my description was quite good. If you like my content, make sure to subscribe and hit the notification bell so you never miss a video, and see you in future problems.